Now that we've talked about hybridized orbitals for single bonds, it's important to know what goes on when we have multiple bonds. So we have our sp, sp2, sp3, sp3d orbitals, right, that form overlapping bonds, and those are sigma bonds. So let's draw something like that. Let's have a carbon that has an sp2 orbital sticking out. It's got a couple more of those sticking out the behind, right, like this, sp2. And then I've got another carbon over here, and it's also got a set of sp2 orbitals, sp2, and it's got one here, sp2, sp2. You know that those are all 120 degrees apart, and that these two overlap like so and become an orbital where we have two electrons whizzing around, and that's a bond, right? And then the carbon is bonded to somebody else over here, maybe a hydrogen and a hydrogen, right? So there's something going on over here. We have a hydrogen and a hydrogen perhaps, right? That's not important. We have overlap there, we have overlap there, and there's a bond. We have overlap there and overlap. But what we're worried about right here is what's going on in this bond between the carbon and carbon. That sp2 overlap forms what we call a sigma bond. So sigma is the Greek letter sigma, and it just, you start out here and you kind of get a little cowlick on top of his head. That's the Greek letter sigma. That's the lowercase sigma. Big sigma looks quite a bit different. But we have one bond that's left over that we didn't use when we hybridized the sp2. Remember, we had our little diagram like this with energy going up. Remember this? And we looped these guys. We said the S, the P, and the P, and that's how we made our sp2 orbitals. And this little P was left over. He wasn't used. So he's still hanging out here. Here's a p orbital that isn't being used. Here's a p orbital that isn't being used. All right? So that's where our double bond is going to come from. It turns out, if we draw this a little more accurately, I've got my carbon and my carbon, and I've got my overlapping sigma bond that we already have going on in here. We have our hydrogen sticking out the other side that we're not too worried about. The p orbitals look a little more like a lobe and a lobe. Here, the other carbon has a p orbital like that and like that. They're not quite as vertical as we make them out to be when we draw them usually. They are more short and fat and close to the nucleus. So if we draw them a little more realistically, we can see that they actually come very close to each other, and we can draw an overlap here and an overlap here. That's the second, this leftover p orbital is used to make the second bond between that carbon and carbon. And that bond now is a pi bond, not a sigma bond. So we have the sigma bond that's in around the axis. We have the pi bond that's here and here. These two lobes, this one and this one, are two lobes of one bond. They are not two different bonds. So this is a double bond. So we can again redraw it. Here's my sigma bond, right? Carbon, carbon, okay, carbon, carbon. And then the two lobes, this one up here and that one down there, these are two lobes of the same pi bond. So an analogy I like to use is it's like a hot dog or a bratwurst or something like that in a bun. So the hot dog is in the center, and just because you've put a bun on either side, you have two pieces of bread that you call one bun. You don't say, when you have the two pieces of bread that go around the hot dog, the two parts of the bun, you don't say, I have two buns. You say, I have one bun and one hot dog. These two are part of the same orbital. The two electrons that live in here are whizzing back around You know, they're really smeared out wave functions, we know that. But they spend some of their time, some of their probability is in this or this lobe of the orbital. Some of their time is over here, or some of their probability of the wave function is up here. And they seamlessly move or exist in both of those without really skipping through the middle. One of those quantum mechanical mysteries, right? How does it get from here to here without really spending much time or any time in between? So we would say we have a pi and a sigma. To be continued.